I'm sure you've heard the news. There's a quiz at the end of this video and the answers will be revealed right after the quiz. So pay close attention. Have you ever stopped to appreciate the wonder of sound? The way it surrounds us, creating a rich tapestry of experiences that we often overlook in our daily lives. How easily we take for granted the symphony of the world around us. From the rustling of leaves to the distant hum of traffic, every sound contributes to our perception of reality. From the whisper of wind through trees to the soaring melodies of our favorite songs, our auditory world is a constant source of wonder and joy. Our ears are remarkable instruments that capture these vibrations and translate them into the language of our brains. They are finely tuned to detect a wide range of frequencies and volumes, making our experience of sound incredibly rich and nuanced. Understanding how our ears work can deepen our appreciation for this incredible sense. The process of hearing is a complex and fascinating journey that begins with the outer ear and ends in the brain. Just like a complex machine, each part of the ear plays a vital role in the process of hearing. The outer ear captures sound waves, the middle ear amplifies them, and the inner ear converts them into electrical signals. Join me as we embark on a three-dimensional adventure to explore the fascinating world inside our ears. We'll delve into the intricate structures and mechanisms that make hearing possible. This journey will take us from the visible outer ear, which acts as a funnel for sound waves, through the hidden chambers of the middle ear, where tiny bones amplify the sound vibrations, and finally into the intricate labyrinth of the inner ear, where the magic of converting sound waves into electrical signals happens. Along the way, we'll uncover the secrets of how sound waves are collected, amplified, and transformed into electrical signals that our brains can interpret. This process is nothing short of miraculous. These electrical signals are then sent to the brain, where they are decoded into the sounds we recognize and understand. It's a seamless process that happens in milliseconds, yet it involves a series of highly coordinated steps. Get ready to be amazed by the ingenuity of your own body. The more we learn about the ear, the more we can appreciate the incredible design and function of this vital sense organ. Our adventure begins with the part of the ear we see every day, the outer ear. This structure, also known as the pinna, isn't just for decoration or for holding up your glasses. Its unique shape, with its curves and folds, acts like a funnel. It expertly channels sound waves from the environment into the ear canal. Think of the pinna as a satellite dish, carefully designed to capture signals. The ear canal, a short tunnel leading inwards, acts as the cable, carrying the sound further in. This canal is lined with tiny hairs and glands that produce earwax. While many people find earwax bothersome, it serves an important purpose. It helps to protect the ear from dust, dirt, and even insects. The outer ear, therefore, plays a crucial role in gathering sound waves and directing them towards the next stage of our auditory journey, the middle ear. As we journey deeper, we reach a critical juncture, the eardrum. This thin, cone-shaped membrane marks the boundary between the outer and middle ear. When sound waves collected by the pinna and funneled through the ear canal hit the eardrum, they cause it to vibrate. Imagine a drumhead responding to the beat of a drumstick. These vibrations are then passed on to three tiny bones in the middle ear, known collectively as the ossicles. These bones, the smallest in the human body, have wonderfully descriptive names: the malleus, hammer, incus, anvil, and stapes, stirrup. True to their names, these bones act like a delicate lever system, amplifying the vibrations received from the eardrum. The amplified vibrations are then delivered to the inner ear, where the true magic of hearing takes place. The middle ear, therefore, acts as a crucial bridge, converting sound waves into mechanical energy and ensuring their efficient transmission to the inner ear. Prepare to be amazed as we enter the inner ear. A complex labyrinth filled with fluid-filled chambers and sensitive hair cells. This intricate system is not just a marvel of biological engineering, but also a crucial component of how we perceive the world around us. The inner ear is a delicate structure, and its proper functioning is essential for both hearing and balance. At the heart of this labyrinth lies the cochlea, a spiral-shaped organ that resembles a snail shell. This tiny yet powerful organ is responsible for converting sound waves into signals that our brain can interpret. The cochlea's unique shape allows it to efficiently process a wide range of sound frequencies. Don't let its small size fool you. This is where sound is transformed into electrical signals that our brain can understand. The process begins when sound waves enter the ear and travel through the ear canal, eventually reaching the cochlea. Here, the magic of hearing truly begins. As the stapes bone vibrates, it creates waves in the fluid inside the cochlea. These vibrations are crucial for the next step in the hearing process. The fluid movement within the cochlea is what ultimately stimulates the hair cells, setting off a chain reaction that leads to sound perception. These waves, in turn, stimulate thousands of tiny hair cells that line the cochlea's interior. Each of these hair cells plays a vital role in detecting different sound frequencies. The precise arrangement and sensitivity of these cells are what allow us to hear a wide range of sounds, from a whisper to a loud concert. Each hair cell is tuned to a specific frequency, like the keys on a piano. This tuning allows the cochlea to break down complex sounds into their component frequencies, which are then sent to the brain for interpretation. It's a finely tuned system that ensures we can enjoy the rich tapestry of sounds in our environment. When a hair cell is stimulated, it generates electrical signals that travel along the auditory nerve to the brain. These signals are then processed by the brain, allowing us to recognize and understand the sounds we hear. This entire process happens almost instantaneously, showcasing the incredible efficiency of the inner ear. But the inner ear's wonders don't end there. Beyond hearing, the inner ear also plays a crucial role in maintaining our balance and spatial orientation. This dual functionality makes the inner ear an even more fascinating subject of study. Nestled alongside the cochlea are three loop-shaped structures called the semicircular canals. These canals are oriented at right angles to each other, allowing them to detect movements in all directions. Their strategic placement is key to their function. These canals, also filled with fluid and lined with hair cells, are responsible for our sense of balance. When we move our heads, the fluid inside these canals shifts, stimulating the hair cells and sending signals to the brain about our head's position and movement. They detect head movements and help us maintain our equilibrium. This system works seamlessly with our visual and skeletal systems to keep us balanced and oriented in our environment. The inner ear truly is a remarkable and multifaceted organ, essential for both hearing and balance. Let's take a moment to appreciate how these individual parts work together in perfect harmony to create the sensation of hearing. The human ear is a marvel of biological engineering, a complex system that seamlessly integrates various components to capture, amplify, and interpret sound waves. The outer ear collects sound waves, acting as the initial gateway for auditory information. It captures the vibrations from the environment and funnels them inward. The middle ear amplifies them, ensuring that the sound waves are strong enough to be processed further. This amplification is crucial for the clarity and volume of the sounds we hear, and the inner ear transforms them into electrical signals. This transformation is a sophisticated process that converts mechanical energy into a form that the brain can understand. These signals are then carried to the brain by the auditory nerve, acting as the communication highway between the ear and the brain, where they are interpreted as sound. The brain decodes these electrical signals, allowing us to recognize and understand the myriad of sounds around us. Think of the entire process as an orchestra, with each part playing a crucial role in creating the symphony of hearing. With each part playing a crucial role: pinna and ear canal, the collectors; pinna and ear canal, the collectors. Like skilled musicians, they gather the initial sound vibrations from the environment. Eardrum, the conductor. Like skilled musicians, they gather the initial sound vibrations from the environment. Eardrum, the conductor. This essential membrane sets the tempo, vibrating in response to sound waves. Ossicles, the amplifiers. This essential membrane sets the tempo, vibrating in response to sound waves. Ossicles, the amplifiers. This trio of bones boosts the sound signal, ensuring it's loud enough for the inner ear to process. Cochlea, the translator. This trio of bones boosts the sound signal, ensuring it's loud enough for the inner ear to process. Cochlea, the translator. This spiral-shaped marvel converts mechanical energy into electrical signals, the language of the brain. Auditory nerve, the messenger. This spiral-shaped marvel converts mechanical energy into electrical signals, the language of the brain. Auditory nerve, the messenger. This vital pathway carries the translated sound information to the brain for interpretation. The brain then deciphers these signals, allowing us to perceive and make sense of the sounds we encounter daily. It's this remarkable collaboration that allows us to experience the richness and complexity of the world through our ears. Each component, from the outer ear to the brain, works in unison to create the beautiful experience of hearing, much like an orchestra performing a symphony. Before we dive into some fun facts about your amazing ears, let's take a moment to talk about something crucial: protecting your hearing. Our ears are incredible, but they're also delicate and can be easily damaged. Here are some practical tips to help you preserve your hearing for years to come. First, avoid prolonged exposure to loud noises. Sounds above 85 decibels, like those from heavy traffic, concerts, or loud machinery, can cause hearing damage over time. If you find yourself in a noisy environment, consider using earplugs or noise-cancelling headphones. Second, take breaks from loud activities. If you're at a concert or working with loud equipment, give your ears some time to recover by stepping away from the noise periodically. Third, keep the volume at a safe level. Whether you're listening to music, watching TV, or playing video games, make sure the volume is not too high. A good rule of thumb is to keep the volume at 60% or lower, and follow the 60/60th rule. Listen at 60% volume for no more than 60 minutes at a time. Fourth, protect your ears during activities that could cause damage. If you swim frequently, consider using earplugs to prevent swimmer's ear, and always wear a helmet when biking or participating in activities that could result in head injuries. Lastly, get regular hearing checkups. Just like you visit the dentist or the doctor for regular checkups, it's important to have your hearing tested regularly, especially as you age or if you work in a noisy environment. By following these simple tips, you can help ensure that your ears continue to perform their amazing functions for a lifetime. Remember, protecting your hearing today can prevent future hearing loss and keep the symphony of sounds around you vibrant and clear. Now that we've explored the intricacies of the ear, let's uncover some fascinating facts about this incredible organ. Your ears never stop working. Even when you're asleep, your ears are constantly picking up sounds. Your brain simply chooses to ignore most of them. Ears play a role in balance. Remember those semicircular canals in the inner ear? They're crucial for maintaining your balance and equilibrium. The tiniest bones in your body are in your ears. The ossicles responsible for amplifying sound are truly minuscule. You hear with your brain, not just your ears. While your ears capture and process sound, it's ultimately your brain that interprets these signals as meaningful sounds. These are just a few fun facts about your ears. The more we learn about these remarkable organs, the more we can appreciate the symphony of sound that surrounds us. Ready to test your knowledge of the amazing human ear? Let's see how much you've learned on our three-dimensional adventure. Instructions. Read each question carefully. Think about your answer before checking the answers section. Have fun testing your ear anatomy knowledge. Gap 3S. Before we jump into the quiz instructions, let's take a moment to debunk some common myths about our ears. Have you ever heard that cleaning your ears with cotton swabs is safe? Or that listening to loud music won't cause long-term damage? Let's set the record straight. Gap 2S. Myth #1. Cotton swabs are safe for cleaning ears. The truth is, using cotton swabs can push earwax deeper into the ear canal, potentially causing blockages or even damaging the eardrum. Instead, let your ears clean themselves naturally or use eardrops if necessary. Gap 2S. Myth #2. Listening to loud music isn't harmful. Exposing your ears to loud noises for extended periods can lead to permanent hearing damage. It's important to keep the volume at a safe level and take breaks to protect your hearing. Gap 2S. Myth #3. Ears stop growing after a certain age. Actually, our ears continue to change and grow throughout our lives. The cartilage in the ears can keep growing, and the earlobes may elongate due to gravity. Gap 2S. By debunking these myths, we hope to help you take better care of your ears. Now, let's move on to the quiz instructions. Get ready for a 10-question fill-in-the-blank quiz. After each question is read, you will have 5 seconds to fill in the blank. Try to complete the blank before the countdown reaches 0. Countdown example: the blank helps to collect sound waves. The quiz will begin at the end of the countdown. Good luck! Question 1. The or blank is responsible for converting sound waves into nerve impulsal. Question 2. The eardrum vibrates when blank. Hit it. Question 3. The three tiny bones in the middle ear are called the malleus, incus, and are blank. Question 4. The blank tube helps equalize pressure in the ear. Question 5. The outer ear includes the blank and the ear canal. Question 6. The inner ear contains the cochlea and the blank system. Question 7. The blank nerve carries signals from the ear to the brain. Question 8. The semicircular canals help with blank. Question 9. The oval window is a membrane-covered opening that leads from the middle ear to the blank. Question 10. The round window allows for the movement of fluid within the blank. Let's reveal the answers to the fill-in-the-blank questions from Chapter 11. Question 1. The cochlea is responsible for converting sound waves into nerve impulses. Question 2. The eardrum vibrates when sound waves hit it. Question 3. The three tiny bones in the middle ear are called the malleus, incus, and stapes. Question 4. The eustachian tube helps equalize pressure in the ear. Question 5. The outer ear includes the pinna and the ear canal. Question 6. The inner ear contains the cochlea and the vestibular system. Question 7. The auditory nerve carries signals from the ear to the brain. Question 8. The semicircular canals help with balance. Question 9. The oval window is a membrane-covered opening that leads from the middle ear to the cochlea. Question 10. The round window allows for the movement of fluid within the cochlea. Congratulations! We hope you had fun. Don't forget to subscribe, like, and share for new learning videos.